Leetcode 1 to sum, the most popular Leetcode question. Let's start off by reading the question. Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So we're given two inputs. One is the integer array called nums, and the other one is a single integer called target. And we're supposed to find the two integers inside the nums array such that they add up to target and return their indices. So we're not supposed to return the numbers themselves, but the indices. So when we look at the first example that's given to us, it's very easy to spot the two numbers that add up to the target. As you can see, that's 2 and 7, which adds up to 9. Therefore, the output would be the indices of these two numbers, not the numbers themselves. And we're allowed to return these indices in any order. So we can return 0, 1, or we can even return 1, 0. Let's look at another example. Here the target is 8, and the numbers are 9, 4, 3, and 5. Technically, we can reach 8 by adding the number 4 twice. However, in the problem statement, we're not allowed to use the same number twice. So this is not valid. The problem statement also states that we're guaranteed to find two integers in the nums array that will give us the target when added up, which means that there won't be an input such that we won't be able to find two numbers that add up to the target. Now, when we scan this array, we can see that number 3 and number 5 do add up to 8. And the result here is the indices of these two numbers, which is 2, 3. Now, what about if the nums array is just one single integer? This won't be given to us as an input because we're guaranteed that there is exactly one solution. So we don't have to worry about this scenario. Now, the way that we solved this example is by simply scanning the integer array with our naked eye. However, we'll need to come up with an actual algorithm to reach that solution. The most intuitive algorithm that we can use is the brute force method, which we do by putting together all possible combinations of the integers in the nums array and checking whether they add up to the target. So we'd start at the first integer and then add it to all other numbers. 9 plus 4 is 13. That's not equal to the target. 9 plus 3 is 12. That's also not equal to the target. 9 plus 5 is 14. That's also not equal to the target. Then we'd move to the next number and also add that to the other numbers. 4 plus 3 is 7. That's not equal to the target. 4 plus 5 is 9. That's also not equal to the target. Then we move to the next number, which is 3. Add it to 5. 3 plus 5 is 8. Now 8 is equal to the target, and so we've found our solution. The brute force algorithm works fine and it's fairly intuitive and easy to understand. However, it's not very efficient because we'd have to use two loops where the outer loop iterates over each integer in the nums array and the inner loop iterates over the rest of the array. In the worst case, the time complexity is big O of n squared. But since we don't use any extra space, the space complexity though is big O of 1. So can we do better than this? There is indeed an algorithm that can solve this in linear time. Consider this approach. We iterate over each integer in the nums array, and for each integer that we encounter, we calculate the difference by subtracting it from the target. The target is 8 and the number is 9, so the difference is -1. Unlike in the brute force algorithm, instead of blindly combining two numbers until we find the target, here we specifically look for the difference. One way to do that is to sequentially search it in the rest of the array, but that's the same as the brute force method and that's not optimal. So what we can do is to use a hash map, because searching for an item in a hash map can be done in constant time. the hash map will store a key value pair where the key is the number and the value is the index. And then we search for the difference in the hash map. And if the difference does exist, we simply return the value, which is the index. But how are we going to populate the hash map? We populate the hash map lazily, which means we only add items to the hash map as we loop through each integer in the array. There is another method where we can do it in advance, but here let's talk about the one pass algorithm, where we only pass through the array once. If we were to pre-populate our hash map before we go through the array and calculate the differences, then we'd have to pass the integer array twice, and that's the two pass method. But here let's look at the one pass method. Let's dry run this example using the one pass method and see it in action. So we simply use a for loop and go through each integer in the nums array and calculate the difference against the target. So for 9, the difference is -1, and then we search for -1 in the hash map. Since the hash map is empty right now, we don't find the difference, and when we don't find the difference in the hash map, what we do is we populate the hash map with our current number and its index. So let's go ahead and do that. 9 is the number and the index is 0. Then we move to the next number, which is 4. 8 minus 4 is 4. We search the hash map for 4, but we don't find it. So we add number 4 along with its index to the hash map and move to the next number. 8 minus 3 is 5. We search the hash map for 5. We don't find it. So we add 3 along with its index and move on. 8 minus 5 is 3. 3 does exist in the hash map. So we've found our solution. What we're going to return is the index of the difference and the index of the current number that we are processing. And that's exactly the expected output. And the time complexity for this algorithm, we're doing one pass iterating over the integer array once. In the worst case, the time complexity of that will be big O of n, linear time. And for each integer in the nums array, we'll search for the difference in the hash map, which is a constant time operation. And this boils down to simply big O of n. However, when it comes to space complexity, we're going to need extra space. Storing the hash map will require n extra space. So the space complexity of this solution is big O of n. Now, when I was learning this optimal algorithm, the one pass method together with the hash map, I was a little bit confused. I was thinking that when we loop over the integer array and we come to a certain number, let's say number 4 in this occasion, we had not explored a portion of the integer array. The hash map has only been populated with values preceding my current number. So how is it okay for me to make the search for the difference if I've only covered the preceding part of the integer array? So let me explain to you why this works. So we're given an integer array and the problem guarantees that there are exactly two numbers which add up to the target. So the two numbers can be anywhere in the array. However, they have to be one after the other. So let's say number 1 is here and number 2 is here. Now, when we follow this algorithm, when we reach the first number, we've only covered this part of the integer array, and only this part of the integer array has been populated into the hash map. But here's where the magic happens. When we reach the second number, we've covered up until this part of the integer array. And this part of the integer array is now covered by the hash map. You can see that the first number is also covered, and that's always bound to happen. And that's the reason why this method works. All right, so now let's code it out. So this is our toSum function, which returns an integer array, the output, the two indices of the numbers that add up to the target. Then we have the nums integer array, which is one input, and the other input is a single integer, the target. So the first thing we're going to do is to create our hash map. Both the key and the value are going to be type integer. Let's call it num to index because the key is the integer number and the value is the index of that number in the array. Then we write a simple for loop to loop over the nums integer array. Then we calculate our difference, which is target minus the current number. Then we check whether difference exists in the hash map. If it does exist, we've found our solution. So we can return the two indices, which is the index of the difference and the current index, and that's I. However, if we don't find a difference in the hash map, then we add the current number to the hash map together with its index. And that's it. So at the end of the for loop, we're guaranteed to have found the answer and returned. So here we can just return null, even though we'd never reached that part of the function. So let's run our code. It passes all the test cases, and let's submit it. It's accepted.